Hi everyone, Mr. Oliver here from the James Prendergast Library, and we're here for another Makerspace demonstration. So as I said a couple weeks ago, we're changing up the way we're doing our Steam videos, and now we're back inside the library and we're showing you some of the equipment and tools and different cool stuff that we have up the stairs in our Makerspace. Specifically, our very popular robots. Now this is 3 of the different robots that we have upstairs. This guy right here is called a Doodlebot, which we'll talk about in a second. This one is Botley, and then this guy over here is called Dash. He's part of a trio of different robots that we have called Dot, Dash, and then
Wonder.
And Wonder, which I always forget what that one is. So these are an example of technology. They're robots, but robots are an example of technology. And so technology is a result of engineering. And it's similar to, if we look back at science, with science, you create a question, or you have a question, and then you try to answer the question, and then you test that answer. So if I have fire in front of me, the question is, well, how do I get rid of it? Well, I can chuck a block at it. That doesn't work, so then I start chucking other things at it. And eventually I'll figure out, well, if I chuck water at fire, the water goes out. It's a very drastic experiment, but it's an example of an experiment. So with technology, we have a problem. Now, frequently it's, I need to move something from here to here. And usually the object is heavy, or it's dangerous, or there's some reason why I shouldn't be moving it just by myself. So if it's heavy, we've created things like cars, or a pulley system, or a dolly, and I'm able to move from here to here. But it's possible that the object is too dangerous for humans to move either by themselves, or just being around it is too dangerous. So maybe it's an explosive, or it's chemical, or it's like nuclear waste. So with that, we can send robots in, and they'll move them from one place to another. Or they'll work on them right there. One not really popular, but kind of famous example of a robot is a demolition bot. So the EOD teams in the military or the police will use them where they think they have something explosive, and they'll send the robot in, and humans can use it to either deactivate the explosive or destroy it, or make it so it's not dangerous to humans anymore. So, meant to back up. So, the word robot actually comes from an old Czech word. It's coined about in the 1920s, and it means forced worker. And so robots are only programmed to do the tasks that they're told to do. Now with our Doodlebot here, it can only do one task, which is to doodle. And so I'm going to take off the cap ends here. I've already got this mostly set up. And I will show you my piece of paper that I tested it on earlier. So they've already got some marker marks on this. But as I put them back together, and I flip the Doodlebot upside down, so as you can see, I now have red here, blue here, yellow here. And as I flip the power, this one's always, there it goes, it'll start to vibrate. So it has a motor right there that's spinning around, and it has these arms. So its only task is to spin around in a circle and then draw these lines. And so there's another component to, I'm going to shut this off, to robots called AI, or artificial intelligence. So it just tells, when an object has artificial intelligence, it starts to think like humans, but it has very basic intelligence. It only knows how to do a limited number of tasks. So this one doesn't have any AI. Once it's turned on, it just does that task that it's programmed to do over and over and over again until it runs out of power or until it's turned off. So, as you can see here, this task was just to draw circles. So I have the red arm, the yellow arm, and the blue arm. Now with something like our friend Botley over here, it can do slightly more complicated tasks. So I'm going to turn him on. He has a sensor down here, right there. And so he's able to sense if there's a black line or a white area underneath him. And so I'm going to switch him to, it has two different modes, coding and line. So if I switch him to line, well, I always forget that he makes noises. And I think I have to hit go. And he will sense the black line and he will follow it. Now, if you have a Roomba or one of those robot vacuum machines, vacuum cleaners at home, they work on the same kind of basic idea. And as we get into having self-driven cars, they will work in the same way too. They will drive along a very specific path and they won't veer from it. Now, I'm going to pause him real quick, and I'm actually going to swap out one of these tiles. And I'm going to change it so it looks like this. Now, as I already told you before, Botley will follow the black line until it hits a white chunk, and then it should go back the way it had before. Oh.
That's okay.
It's okay. He will actually, he should, when he gets to the end over here, turn back around too. Yep. See, he sensed that there was no more black line in front of him, and he turned back around. So I'm going to pause him real quick. So that is very basic artificial intelligence. It has a programmed task in it like this does, so to drive along the line. But then it's also told if there's an error in the way, so there's no more black line, or there's, in this case, or in the case of a Roomba, if there is stairs or a hole, to go around it. So this is the next step. From there, we have our friend Dash. And I'm going to put Dash here. Now Dash is rather small in terms of robots. I know he's much bigger than either two of these, but in terms of, say, some of the other robots, so if you look at car manufacturing, robots are huge. They could be as tall as this room or even bigger, because they're making big parts. One of the hopes for when we go to space and things like that is we'll be able to have robots that'll build settlements, huge towns, cities, roads. And some of them will be as small as Dash, but we'll need much bigger ones too for bigger projects. But because of that, part of Dash's brain is inside this iPad. And so we can program the iPad to tell him what to do. And so he can, if we, oh, I gotta turn him on.
Howdy do.
He's always a very nice guy. He always says hi when he wakes up. So if we watch right here on this light right there with Dash, oh, you got to turn around to them. It'll be okay. All right. So if we look right here at this light with Dash, it'll go pretty quick, but his light will change. And it'll keep doing that because I've programmed him to do that. So that is kind of the same as our Doodlebot here. He has a very specific program and he does it. But It's actually a more complicated program because it's not just turning around in circles, but it's changing the colors. So I'm going to stop that. And I also had him make some noises that are kind of cool.
Bye-bye.
So as you can see, that program actually took a little bit longer than the first one. So with our next generation of robots and AI, we'll be able to program tasks that are far more complicated than any of our basic robots. And we'll actually be able to tell them to do something and then wait a little bit. So say like if we're drilling and we want to find water, they'll need to be able to drill and then wait. That way we can detect if there's water there. So this is all just a very basic introduction to some of our robots here and some of the things you can do with robots. Hopefully once we have our makerspace open again, we'll be able to have you guys come in and we can show you some of the some more cool things that we can do with our robots. All right. Until next week, have a good day.